In this lesson, I'm going to look at some of the properties, review some of the properties of circles and angles inside of circles. So this first diagram, we have a 42-degree angle. Notice how this angle touches the edge of the circle, just like that. That is actually called an inscribed angle. So if you can remember back from geometry, if you have an inscribed angle, then the intercepted arc that you have over here is going to have to be twice this amount. So if I double 42, I end up with 84 degrees. So the measure of arc WV is going to be 84 degrees. Also, because this is a line that goes through the center right here, we know that this other arc over here is 180 degrees. So this inscribed angle would have to be a right angle of 90 degrees. And then you know then that automatically this is 48 degrees, and then you could figure out the other angles as well. But if you have an inscribed angle on the outside edge of the circle, the intercepted arc is always double the inscribed angle. So let's see if we can apply some of those properties to this next one. We're told that we have a 35-degree angle right up in this top corner. Okay, right up here, that's 35 degrees. So what we could do is we could go and say, well, that's an inscribed angle, and if I follow that down, it goes to the arc FP, so that's got to be double, so this has got to be 70 degrees. Then I guess what I'm going to have to use here in this situation is the fact that I do know that this line goes through the center, because there's a center dot here. That means that this has to be a right angle. Now if that angle right here is 35, the other angle has to be 90 minus 35, which must be equal to 55 degrees. So we got a 55-degree angle right there. Then what we can do is we can again use the fact that we have that 55 would be an inscribed angle all the way from P to D. And that's actually what we wanted in this case. So if we follow that down, when we double that, we would get 110 degrees for that arc on the outside edge. Okay, let's look at this next example. The next example we have is dealing with a triangle that is kind of intersecting a circle. The center is right in the middle, that's center O. But the nice thing about this one is that there's a line that just touches the circle at that one spot, at A. That's called the point of tangency. So that means that this is going to be a right angle. I want to find the radius. Well, I know that this leg is 16, 8 and 12 add up to be 20. So what I have really then is I have a right triangle, and we know that on the right triangle that we can use the Pythagorean theorem, where we have A, B, and C. So A squared plus B squared is going to be equal to C squared. So what I'm missing is I'm missing either the side A or side B. I know the hypotenuse has to be 20 because that's across from the right angle. So I'll just say this is x. And I'll say x squared plus 16 has to equal, or plus 16 squared has to equal 20 squared. So then x squared must be equal to 20 squared minus 16 squared. And x is the square root of all of that. So then when I go ahead and if I were to type this into my calculator, I would take the second x squared, which is my square root key. I'm going to do 20 squared minus 16 squared, and I get 12. So my answer to this problem then, for this side of this triangle, is 12. 12 is the radius then. And what we just realized here is that we didn't really need to do all of this work, did we? If you looked at this, this is a radii right here. This is also a radii. These are exactly the same lengths. We could have then looked at this problem right away and said, well, this is 12. We didn't even need to use the Pythagorean theorem here, and then we'd be done with the problem. Okay, let's look at this last example then. The last example, we're told that we have a side, an arc is 13x minus 10, another arc is 7x minus 10. Well, because again it goes through the center, we know that from all the way from N to L is 180 degrees. So I'm going to just start off by writing a simple equation saying 13x minus 10 plus 7x minus 10 has to equal 180. If I combine like terms here, I would get 20x minus 20 is equal to 180. So 20x is going to be 200. X would be 10. Okay, so I got the x value to be 10, but I want to find the measure of angle NLM. So NLM is going to be right here. Well, let's plug the 10 in for the x right here. So 7 times 10 minus 10 would be 70 minus 10, and that's 60. That's the arc. Now remember, this is an inscribed angle, so the inscribed angle is half of the intercepted arc. So the answer should be 30 degrees.